Hello there, I am Suhayl Khan. I will be discussing the nature of emissions reaching this Earth from the Sun and the particulate nature of solar wind. Emissions from the Sun. There are two types of emissions that are produced by the Sun: electromagnetic radiation and solar wind. Electromagnetic radiation. Electromagnetic radiation is a form of energy. It takes forms such as radio waves, microwaves, X-ray, and gamma rays. Sunlight is a form of electromagnetic radiation. Between visible light and X-ray light, ultraviolet light is a component of sunlight. It is invisible and has frequencies of about 8 times 10 to the power 14 to 3 times 10 to the power 16 Hz, and wavelengths of about 380 nanometers to 10 nanometers. A range of electromagnetic waves are produced by the Sun, from short wavelength waves to long radio waves. The visible spectrum is the most intense wavelength range produced. The maximum intensity has the length of about 460 nanometers. Electromagnetic radiation travels at the speed of light, 3 times 10 to the power 8 meters per second. This means it takes roughly 8 minutes to reach Earth from the Sun. This graph shows different wavelengths being absorbed by different atmospheric molecules at different altitudes. Gamma rays and X-rays are absorbed by the oxygen and nitrogen at an altitude of about 100 kilometers. Ultraviolet radiation is absorbed by the ozone at about 100 kilometers. Infrared wavelengths are absorbed at 20 kilometers altitude by water vapor and carbon dioxide. Visible and near-infrared, microwave, and radio waves are not absorbed as the atmosphere is transparent to these wavelengths. The solar wind and space weather. The space between the Sun and Earth looks empty, but it isn't. The Sun outputs huge streams of radiation. This is known as solar wind. Solar wind consists of particles such as helium and hydrogen atoms and ions, and also high-energy X-rays and UV radiation. The corona reaches temperatures of about 1.1 million degrees Celsius. Due to the rapid movement of plasma and particles, the Sun's gravity cannot hold onto them, and they stream away from the Sun. The wind is constant, but its properties are not. The wind travels across the solar system at speeds ranging from 400 to 700 kilometers per second. Mars has been stripped of much of the atmosphere it once had. The Earth has escaped some of the solar wind due to its magnetosphere. This is caused by the Earth's magnetic field, diverting most of the solar wind around the planet. The solar wind varies in strength, magnetic field properties, velocity, temperature, and density, along with the 11-year sunspot cycle. During periods of solar maximum, the Sun undergoes coronal mass ejections known as CMEs. CMEs are massive explosions of plasma and magnetic fields. They can escape from the Sun during solar flares and filament eruptions. When a coronal mass ejection impacts the Earth's magnetosphere, it causes enhanced aurora and geomagnetic storms. CMEs travel towards Earth at varying speeds, from 100 km per second, 300 km per second, or even 3,000 km per second. Large active sunspot regions have more magnetic field concentration, meaning the fastest CMEs are erupted from these regions. These fast CMEs can reach Earth in about 14 to 17 hours. Coronal mass ejections have a fixed magnetic field that is stronger than the background field of the solar wind, meaning the CMEs will expand in size as they move away from the Sun. Some CMEs can expand enough to fit half the volume of space between the Sun and Earth. Coronal mass ejections often, but not always, accompany solar flares. Solar flares. A flare is a rapid, sudden, and intense variation in brightness. A solar flare occurs when the buildup of magnetic energy in the solar atmosphere is suddenly released. The solar flare releases clouds of electrons, ions, and atoms through the corona of the Sun into space. Radiation across the entire electromagnetic spectrum is released, from radio waves to gamma rays, but the majority of flares are not visible due to most of the energy being spread of frequencies outside the visual range. The usual energy release is 1 times 10 to the power 20 joules, but a huge major flare can release up to 1 times 10 to the power 25 joules. Solar flares are classified as A, B, C, M, or X. X-rays and UV radiation emitted by the solar flares affect Earth's ionosphere, which is Earth's upper atmosphere, and disrupt long-range radio communication. The X-class flares increase the ionization of the upper atmosphere. This interrupts with short-wave radio communication. The ionization also heats up the outer atmosphere, increasing drag on low-orbiting satellites, causing orbital decay. The release of radio waves can disrupt the operation of radars and other devices that use the same frequencies. Note that ultraviolet waves can cause sunburn, tanning, premature skin aging, suppression of the immune system, eye damage, and skin cancer. Solar flares can produce highly energetic particles in the solar wind that impact the Earth's atmosphere and incur radiation hazards to astronauts and spacecraft. Massive solar flares that are accompanied by coronal mass ejection can trigger a geomagnetic storm. A geomagnetic storm is a disturbance of the Earth's magnetosphere that can disable satellites and shut down terrestrial electrical power grids for long periods of time. The energetic particles in the magnetosphere contribute to aurora borealis and aurora australis. These are captured by Atmospheric Imaging Assembly known as AIA. AIA 193. The video displayed here highlights the outermost layer of the Sun, the corona, as well as hot flare plasma. Hot active regions, solar flares, and coronal mass ejections appear bright here. The dark areas called coronal holes are places where little emitted radiation, but are the main source of solar wind particles. AIA 211 and AIA 335. These two videos also highlight the active region of the corona. Active regions, solar flares, and coronal mass ejections will also appear bright here. Coronal holes are also present here. AIA 131 and AIA 094. These clips study solar flares. It measures extreme hot temperatures and cool plasmas. EVE diodes 3-day plot. This graph shows a time series of 5 strong EUV emission lines over a period of 3 days. EUV stands for extreme ultraviolet. A dark value is shown. This is a detector that is blocked from seeing the sun. This also shows the energetic particles from the sun that can infiltrate the EVE instrument. EVE stands for Extreme Ultraviolet Variability Experiment, causing false data. During solar storms, this value will increase. This is the data in a table format, distinguishing by color, NM, EUV, element, and Kelvin. Green is not present in this graph. I will now conclude with the effects of space weather. Satellites. High levels of radiation can cause electronics to fail through discharge arcs or a buildup of insulation. Solar energy can heat up the Earth's atmosphere, expanding it, causing satellites to experience extra drag. This puts them in lower orbits and even increases the possibility of it burning up. Power grids. Changes in magnetic fields around conducting networks such as phone lines, train tracks, or power grids will induce surges of current in the conductors, up to hundreds of amp meters in size. This can cause transformers to fail. Radio communications. The solar wind disrupts radio communication as it changes the ionosphere, an electrically charged layer of the atmosphere, 100 to 500 kilometers in altitude. Aurora. Charged particles in the solar wind and from solar flares get carried by the Earth's magnetic field towards polar regions. Interactions between molecules and atoms in the ionosphere create a distinctive auroral glow. So there we have it, the nature of emissions reaching the Earth from the Sun and the particulate nature of solar wind. I'm Suhayl Khan and I hope you enjoyed this video. Thanks.